Let's start class, okay? Today we're going to mainly focus on the story problems and how to solve kind of so-called equations based on the given information, okay? So my first problem I want to discuss is, suppose you have a coordinate line, right? This is the distance, okay? And you have a bunch of points, A, B, C, D, okay? If I know the distance between A and the C, okay, this is the distance, okay? We're talking about this. If it's going to be 12, okay, centimeters. If you also know the distance from B to D will be 14 centimeters. Are we able to find out the distance between B and C? Okay. So think about this problem, right? So there's overlap part, okay? So the question is, are we able to find it? Okay. So we are given, do we need more information? Yeah, let's check, okay? Also, we need more information, otherwise you cannot. And we know the distance between A over D, okay? So distance between A over D, so it's not like, add them together. That before, otherwise 14 plus 12, right? It'll be 26. So actually it's only 20 centimeters. In this case, then you can solve, then you can solve the problem. Okay. So just the first stop, yeah. So just type in one answer. Okay. So the idea is just okay. So if you do 12 plus 14, right? If you do plus 14, then you add them together. But there's overlap part. Overlap part is the distance between C and B and C. Okay, so 12, right, plus 14. What does that mean? You can from A to C, then from B to C, add them together, right? That's overlap part. So if you subtract the overlap part, then you should get 20. Okay, so that means so this is kind of question. If you can do the following, the distance. You can also think about the following way. If we add them together, right? 12 plus 14 is much larger than 20, but because there's overlap part. The overlap part is distance between B and C. Okay, so then you can figure out what is B and C. Okay, so there were some similar problems like that we're going to do. So here 12 plus 14 is 26 equals 20 plus the overlap part, and clearly that's going to be 6. Okay, let me try it again. Right? So this is a part overlap, right? But when you add them together, right, from A to C, from B to D, right? So this part is double counted. Think about, right? So it's going to be, because it's double counted, it's going to be more, it's going to be, 12 plus 14, 26, because this part is double counted. So it should be 20 plus the double counted part. So double counted part is the distance between B and C. Okay, let me draw another picture. Okay, so if you have two sets, like something like that, right? So this set is A, that set is B. Okay. That set is B. Then this notation in mathematics we call the unit of A and B. Okay? And this intersection part is called, use this notation. Right? So it's called the intersection of A and B. Okay? So if you want to count how many points, elements in the set, right? So this so this is going to be the unit, all the elements in the unit is going to be A plus B, add them together, but there's overlap part. Right? So you have to subtract the overlap part. Okay. So if we just A plus B, the overlap part is double counted. So we can also let me write. Yeah, let me write this. So if the elements in the set A and the elements in set B, add them together, will be the elements in the unit of that, but there's overlap part. Okay. So again, let me draw the picture here. So if you draw the line, right, and you have a bunch of points, P, Q, R, and S. This, okay. So if you know the distance between this will be 20, right? And the distance between this will be 15. If you also know the distance between P and R, that'll be it's going to be less than 20. Okay, 35. Let's say 30. So in that case, what is the distance between Q and R, right? So the idea is like that. You add them together, 20 plus 15, okay? 20 plus 15, just add the distance between P and R and Q and S. But since Q and R, this is the overlap part. So this should be total be 30 plus the overlap part. Okay, overlap part, then this must be 5, yes. Okay, so this is the idea. Now if I move up, okay, if this is a P, here's R, here's a Q, here's S, then it'll be different story, right? If this is a 20, that'll be 15, but then total that is going to be 40, right? Even 45, yeah, 40. Let's say 46. So what is this in between I and the Q? Now in that case, you have to, there's no overlap part. Actually, that part is missing. So 20 plus 15, right? It's not going to be the total 46. You have to subtract that part, okay? Then you get 40. So that part is going to be, right? It's going to be 11. Right? Right? So the distance between this R and the Q is going to be 11. Okay. Yeah, there's another similar problems we're going to work out. It's about the students who, some students have a sister, brother, some students have a brother, sometimes sisters. Let's work out this problem. Okay, so we use the same picture. Let's go back. Let's go back to the set A and the B. Okay, so my notation here. This means the number of elements in A. So A represents a class A, B represents class B, and right, and maybe no, A represents a group of the students, for example, taking math class. B represents a group of the students taking Spanish. Okay, but there's some students also take both classes. Okay, so this, then if we know that every student in the class take either math or Spanish or both, then you can figure out the number of students who take both classes. Okay, so here's a question. Okay, there are 24 students in a class. Okay. Each student takes at least one of the two classes. One of the two classes. Math or in Spanish. Okay. Some students maybe take both. Okay. So we know that 15 students take math, and 13 students take Spanish course. Okay. My question is, how many students take both classes? Take both courses. Okay. All right. Well, I got so many answers so quickly, right? So the idea is, you have these two groups, right? Math classes and math courses, right? So those students take a math course, and those two students take Spanish course. Okay? So you have total here 15 and 13. But if you just add them together, this will be the more than the student of the whole class, right? So 28. Okay. So there will be overlap part. Okay. So let's use a set notation. That's called A and B. A represents the students who are taking math course. B represents the group of students taking a Spanish course. So A, the union of A means the whole class. Okay, and this intersection means those are students taking both. Okay, taking both courses. Okay, right? It's in the intersection. Okay, so A and the unit of A and B. Okay, it's the whole class, either in A or B, because every student have to take at least one course. Okay, so the formula says that. Okay, the formula says that there are a couple ways to write the formula. So the elements, the number of students in A plus the number of students in B, this will be more than the number of students in the unit of this, right? In the whole class, because this is over double count. This is double count intersection part. So you have to add. So add is the intersection part. This is a notation. Okay. A plus B is going to be 20. Yeah, it's going to be 15 plus 13, right? So that's going to be 28. That's 28 in the middle. But this, the unit, the whole class, we only have 20 students, 24 students. So, and the intersection part must be, there are 4 students there. Okay? Yeah, there are 4 students. Okay. Here's another question, slightly different. Okay. So there are 24 students, right, in a certain class, right? 16 of the students have a system, and 18 students have a brother. Right? So in this class, only only Aaron and Kevin do not have any sibling. Right? Right. My question is, how many students in this class have both a brother or sister? Yeah, they're different type of problem. This is another tricky problem is sometimes Aaron and Kevin are brothers, and they're more complicated. You know, but this is we have to assume that no brother sister together in the same class. Otherwise, this is much harder problem. Okay, so how many students from this class have both a brother and sister? Okay. So first of all, the only change here is you have to exclude these two students because they don't have brothers and sisters, right? So B is the class students having brothers, okay? Yeah, you can write in the set. And S means the students having a sister. Okay, so you have to write. You have draw the set. Okay, B and S. So this intersection part is a set of is a group of students having both a brother and sister. Okay. So yeah, you actually want to find the number of students in the intersection part. Okay, so you write down this unit, right? Have a formula. Okay, you can write it this way. Let's begin with B. The number of students in the group of B, the number of students in group S. This should be the number of students in the unit of that, and then plus the number of students in the intersection part. Okay, I already explained to you why I have to plus that, because when you add those two group of students separately, right, together, add them together, there's overlap part. So you have to, in order to, it's going to be larger than the number of students in the unit. So plus the overlap part. Okay. Another way you can think about is if you count the number of the students in the unit of these two sets, then of course you're going to add the number of students in the set B and also add the number of students in set S. But then you see that the student in the intersection part are double counted. So you have to subtract the students in the intersection part. Okay, so now let's go back to the problem. So you have a 24 student, but the Aaron and Kevin must be excluded. So you have 24. And the students who have brothers are going to be 18. The students have sisters, 16, right? Yes. Okay. There's 16 students have a sister. So you have to minus the intersection part. Okay. So let's figure it out. It's not 24 have to minus. Yeah, 24 students have to minus 2. Okay. So you subtract the 2 here. Okay. That's a total. So we only consider students either have a brother or sister. So 22, and this side is going to be 34. So you have to minus what number, right? You have to minus 12. Okay? So there are 12. Okay? The answer is 12. Okay. All right, so this is about a very important set of problems. I have a, how to count the intersection. Okay? This formula will be used over and over again. For example, if we have, when we're talking about the number is divisible by 4 and the number divided by 3, something like that. How many numbers divisible by both? Something like that. Okay, so let's look at another geometry type of problems. Okay, remember how to count the area. Do you remember how to count the area? Yeah, how to count the number, the squares, right? If you have okay, something like that, if I draw that, how to count the squares. You cannot just count them, right? What you do is you just look at on this vertical side, 1, 2, 3, 4, 5, and here you have 1, 2, 3, 4, 5, 6, 7. So the number of squares is going to be 5 times 7, 35. Okay, just multiply them together. Okay. This is also the motivation. This is also the reason how to define the area. When the area really means how many squares there. Okay. Suppose those squares are unit square 1 by 1, right? And you have a rectangle like this. On the vertical side, you have 5 squares. On the horizontal side, you have 7 squares. So 5 times 7 is going to be the number of all the squares in this rectangle. So rectangle, when rectangle gives the area really tells you how many squares inside this rectangle. Okay, so area really, roughly speaking, is the area of the area is going to be the number of the squares in the rectangle. Okay, and the similar idea, if you have a box, okay, this is a rectangle. Okay, it's also called prism. Okay, and so if you draw 2, 3, 4, 5. Right. So we try to count how many cubes, unit cubes. Okay, each of them is a unit cube. Right, how many cubes? So yeah, this actually tells us the area. Here is it. Yeah. Okay. So the number of the cubes. Okay. How do you do that? Okay. You cannot count. There's too many there. Somehow you cannot see it. There's always some problem like that. You cannot see it. So you have to do the computation. Okay. So you count this side 1, 2, 3, 4, 5, and 6. Okay, the other side, yeah, here's 1, 2, 3, 4. This is height. The width is 1, 2, 3. Okay. So to get, first of all, let's look at the front side. Okay, 6 times 4 really means how many squares on the ones on the side facing to you, right? So each square actually represents 1 cube. Then you have how many layers there? There's 3 layers. So you just multiply by 3. Okay. So then you get 24 times 3, 72. Okay, so there are 72 cubes. So cube. Okay, so this is also called the volume. If this each cube is a unit cube, okay, it is going to be called the volume of this prism. Okay, if each cube, yeah, is a unit cube. Okay, and the above here is if each square is a unit square. Unit square means it's 1 by 1, right? And cube is, you know, this is a it's 1 by 1 by 1. All right. So this is where we can. So we will, you know, volume. If we want to understand the meaning of the volume, okay, the volume of some prism is just the number of unit square inside. Of course, sometimes the edge length is not integer, okay, then still it's about the same meaning. It's not the case. You cannot say 2.5 cubes there, right? So this is a, but if they're both, each side is the integer, then this tells you how many cubes inside. Okay. My next question is, so I still have a cube like that. 1, 2, 3. Oh, that's okay. So what I'm going to paint, I'm going to paint all sides. It's painted. Right? So what I'm going to do is, this is a prism, okay? And how many? 1, 2, 3, 4, 5, 6. 1, 2, 3. Okay? And this side is a 1, 2, 3, 4. So this consists of unit cubes, okay? It consists of unit cubes. So I painted outside, right? Then I open it, you know, then I got lots of little cubes, right? And some cubes are painted one side of the face, some are not. Okay, some cubes are painted on this side, some cubes are painted on the other side, right? And some cubes there's no painting at all. My question is, how many cubes, right? How many unique cubes without color? Without the yellow color, okay? All right, so you just need to count those inside, okay? So think about you remove all the cubes all side, right? And what is inside? Inside, if you draw the picture, and you will get, right? So this side you only on horizontal get 2, and here you get 1, 2, 3, 4. Okay, and the other side you only get this layer. Okay. So those are the the cubes, yeah, which inside without painting. Okay, so the answer will be 4 times 2 times 1, that's going to be 8. That's easy to, right? Find out. Okay. My next question is challenge. Okay. My next question is, after you disassembled, okay? My next question is, this is the first question. Second question is, how many faces are unpainted? Okay. So this is a difficult. The reason is they are, you look at all those unit cubes after you, right, open it. Some faces, some cubes have 3 faces painted, right? If it's come from the corner, yeah, 1, 2, 3. Some are only 1 face are painted. Some, if it's inside, coming from inside, and no face is painted. But each cube, how many faces is that? 6, right? So those little cube, unit cubes, there are some are 3 faces painted, some only 2 faces are painted. How come 2 faces? If it's coming from here, this one, right? This one has 2 faces painted, left and right, right? Top and bottom, they are not, it's inside. Okay, so this is a challenging problem. I'm going to ask you to think about, to count. This actually is given to the middle school students math competition, regional. But if you are good enough, you can figure it out, okay? Yeah, but don't, how many pieces total there? How many pieces, right? How many cubes? Because this side is 6, right? And the other side is 4, and the other side is 3, right? Well, you get 72 there. You cannot just look at the 72 little cubes and then count them. You have to find some genius way to do that.
3 faces, 2 faces, 1, 0.
Yeah, 0 faces. Yeah. Okay, but yeah, this is a difficult problem. Okay, but just do the multiplication, addition, subtraction, then you can get. All right, first of all, here's my hint. For those unit cubes, how many faces total? Right? You have a 72 unit cubes. Each unit cube, there are 6 faces there, right? So total, there are total 72 times 6 faces. Okay, you can get. Okay, that's a total. Some of them are painted, some are not painted. Okay, but those painted faces, they form the faces of this large rectangular box. So you just subtract them, right? So in order to count the painted faces, you just need to count. This is count the faces of the larger part. Just put them back. Okay. So the number of the faces on the number of the squares, the number of the squares on this large box, on the large box, surface of large box, right? Then it's easy to count. Why? Because the front, the back side, and the 6 times 4, right? So you have to, 72 times 6 minus the front 6 times 4, and that times 2. That's the front back side. And then let's look at the left and right side. Left and right side is 3 times 4, okay? Minus 3 times 4, but I have to times 2 because of left and right. And the up and down. Then the up and down, up, here's a 6, here's a 3, right? 1, 2, 3, and the 1, 2, 3, 4, 5, 6. So the top part, 6 times 3, right? And the bottom part, also 6 times 3 times 2. So those numbers in the parentheses are the unit squares on the larger faces of the rectangular box. And those faces are painted. Okay? Okay? Then you get an answer. Okay? So this is the answer. Okay? So the number of unpainted faces is given by this. Okay, I'm not going to finish computation. You know how to do the multiplication, subtraction. Just use subtraction. Subtraction. This is the idea. Is used, in many places. Okay, you cannot count it directly. Use a substitution to count. Okay. All right. So those students are online, okay, pay attention to my lecture. Do not type nonsense, okay? Jackie, so please stop it, okay? All right, so now we're going to solve a story problem. It's how to analyze the data and to figure it out. Okay, so here's one. Okay, if John buys 4 basketballs, okay, if you buy 4 basketballs, he will have $4 left. Okay. Then, if he buys if he buys 6 basketballs, okay, then he finds that's not enough money, so he will have to borrow $26. Okay. So the question is, how much does the one basket cost? Okay. Now those are the problems. Take a problem for basic math class students, but in that class they're going to use a variables, equations, linear equations, system linear equations to solve, 2 equations. But here we're trying to not using equations to solve. Okay. Okay. Michael cannot be 5. If you get a number answers, right? You just needed to check that if $5 is correct, right? If it's $5 correct, and 4 times 5, right? And plus that's how much money does he have? But that's not matter, right? Is $5 correct? So like 4 times $5, right? And then he has $4 left. That's total money he has. Now, if he buy 6, so 6 times $5, right? Then it's not enough money there. So you have to, you have to borrow. So $26. That's my picture here. Okay. So in other words, you have to add $26 to whatever he has in order to buy 6 basketballs. If it's $5, correct. But you can do the, you can check the, it's obvious it's wrong, right? So here's $24. If you add $26, you can buy 6, which is not, right? 36 minus 26, it's so definitely that's wrong, okay? $5 is not the cost of a basket, okay? Richard, then you have $3 is even worse. Cannot be that cheap. Okay. Also, you have to use a common sense. In the basketball, does not cost much more than $3. Okay. Yeah, I'll give you a few minutes. No, just a few seconds. Think about it. Yeah, let's we know 4 baskets. We don't know how much money, right? So let's put, okay, 4 basketball. Okay. So the total, you don't know the dollars, right? How much money, right? But then John has some, how much money John has? John, if it's 8, yeah, 6, that's $4, right? So that is the total money he has, but we don't know how much money does John have. He has a money equivalent to 4 basketballs and plus $4. Okay, but if he wants to buy 6 baskets, right? He says there is a shortage of $26. So that means in order to buy 6 basketballs, he has to borrow $26. So in other words, you have to add $26 here, then the money he has here is the equivalent to the money he has here, right? You do the comparison. Yeah, think about it. You draw the picture, you know, yeah, right now, if he increase, so first of all, we assume that John has so much money, the money equivalent to 4 basketballs plus $4, right? Then if he add $26, he can afford it to buy 6 basketballs. So then you look at this picture, you find out this money is equivalent to this 2 basketballs, right? So that's why 2 basketballs is equivalent to $4 plus 26, which is $30. So then 1 basketball is going to be $15. Okay, and then you look at this number, maybe it's reasonable. Yeah, of course, good basketballs cost much more. So you're trying to do the comparison than to solve the problem. Okay. Okay. There's another complicated problems. Let's try this. The next one is not that complicated. Let's see. So here, Alice has 10 pieces of paper, right? But she's going to cut some of them into 4 parts, okay? Here's a piece of paper. She's going to cut them into 4 parts. So they get some, you know, cut them into 4 pieces, okay? And this is, yeah. Yeah. She cuts some of them into 4 parts. And now she has a total, let's see how many. She has a 31 pieces of paper. And my question is, how many pieces of paper did she cut?
7. 7.
Hmm?
7.
7? All right, so the idea is, first of all, you have 10 pieces, right? So you have 10 pieces, and so on, 10 pieces, okay? 10 pieces. Now you find out, you needed, yeah, so each piece, those who cut it tend to be 4 pieces, right? If it's cut, right? So increased, if she cut the number of the, if she cut some paper, right? Then every paper she cut it, you get an increase of 3 pieces, right? Think about like this way. So you increase by 3 pieces. Then from 10, and now you get 31. How many pieces increased, right? So 31 minus 10 is going to be 21. So 21 pieces more she got through this cutting, right?
Every time she cuts, she
Yeah.
gets 3 more.
She gets 3 more. So she has to cut 7 in order to, okay? So she has to cut, yeah. So she cut 7 pieces. Yeah. Now, if you want to solve an equation, just like a basic math class, what you do is you count those uncutted, it's called M. Those who you cut it M. So N plus M equals 10, okay? And then after you cut M pieces, you get 4 M pieces. Then N is still unchanged because those are paper not cut. Then you get 31. So that's called the system of linear equations, okay? Then you do the computation without to do some analysis. Just write down, translate each sentence into equation, okay? Then that's called equation 1. That's called equation 2. Now, N is number of, yeah, N represents the number of the pieces of uncut paper. Okay. Okay. M means the number of pieces paper be cut. Okay. So then you solve the equations like a subtraction. Okay. Subtraction like equation 2 minus equation 1, and then briefly describe it. Then N minus N is 0. And this 4M minus M is 3M. And 31 minus 10 is going to be 21. So M should be equal to 7. Okay? Yeah, this is the way we solve this equations in the future. But I'm not going to spend too much time on that. So let's do the next problem. Okay? It's also a story problem. Okay? All right, so we have a, yeah. So John has 3 kinds of cookie. Okay. So you have a large size, a medium size, and small size. Let's cost, okay. This cost $3 each. This cost $2. This cost $1 each. Okay. So okay. So John, yeah. So not has, okay, bought, okay, bought. Okay, so John bought total, let's see how many pieces. Yeah, John bought 10 pieces, 10 cookies, and paid total $14. Okay. Yeah, how many large cookies did he buy? Did he buy? It's now have 3 variables there, right? You know, you can also guess and try, but it takes too much time. At least do some kind of analysis.
Yeah, more than one answer.
Huh?
There's
No,
more than
one
one
answer.
answer.
It's possible.
You could do
So
one
we have
to the large cookie.
yeah. No, you have to buy at least one kind of cookie each. You cannot say, you know, I just only buy large cookies. Yeah, he already bought 3 kinds. It means, yeah, it means, yeah, they are at least one. At least he bought one medium size. Okay, so
One. He bought one big.
he bought one big. All right.
He bought 9 small ones
Yeah.
and a medium one.
Yeah, so let's call, you know, this is what we do, okay? We don't know how many of them. This is large 3. Okay? And those are small one, $2. You don't know how many of them. And then those are the $1, right? And total $14 he paid. Okay. And that's 14. Okay, each one has a value, you know, so this is 3. But then the number of total cookies, add them together, just 10 cookies. Okay? But those small cookies only cost $1 each.
So just do 3 plus 2 plus 1 equals 6, and then 14 minus 6 equals 8, and then do the rest in small cookies. Small cookies are the most accurate.
Yeah. So if each cookie costs $1, right? Then you have to pay $10. Think about it like that, right? So now you have to buy some cookies more expensive, some cookies less. So I think here you each get $2 increase, and this is $1. $1 total, the difference will be $4. Okay, in order to make 4, okay, if you buy 2 large cookies, then you already spend $4. You cannot buy any medium size. Yeah, no, 2 large is impossible. So the only possibility here is 1 large cookie. Okay, then 2 medium size cookies. Okay. It's 2, yeah, 2 plus 2 is 4. So 2 medium size cookie. And then 7 small size cookies.
But it has to be exactly.
Or just by one medium.
Yeah. Yeah, it can be one medium.
Does it have to be exactly
It's
10?
small, right?
Does it have to be exactly 10 though? Because if you do large small cookies and
You have to buy one large cookie, okay?
Right, yeah.
oh, it has to be exactly 10?
Yeah.
Oh,
Then you don't have other choices.
well then still a large cookie.
Yeah, you write down 2 rows, right? First of all, you don't know a certain number of cookies for large cookies, certain number of small, medium-sized cookies. Okay, then total will be 14 if you count them at $14. But the second row is about the number of cookies. But you assume that each cookie costs $1, then you got also $10, right? 14 minus 10. We look at the difference. So $4 increased. So you have to increase the price for the larger cookie, increase the price for the medium size. But for medium size, they only increase $1. Then it depends on how many medium size cookies, how many large size cookies. Then you look at that certain increase $2, $2, and increase $1, right? Add them together should be $4. So then that's easy. This is a part. This math is easy to figure out. You must have you can only have one large cookie. Okay. Another option is, can you have a 4 medium-sized cookie? No, if you have 4, then you don't have any larger cookies. Okay, you have to have at least one large cookie. So the solution is unique. The solution is unique. Okay. Those are this is it's a kind of story problems. Yeah, most of the time we just do the comparison. You see, we compare them and take a difference. So if you solve it using mathematics, using equations, how do you do that? You just need to write down the 2 equations, right? L means the number of larger cookies, right? The number of larger size cookies. Okay, M means the number of medium-sized cookie. Okay, then S is the number of small. Okay, then how do you count the total, right? $3 times the number of the large size cookie, and $2 times the medium size cookie, and the small size cookie should be called $14. 14. Okay, so this is a 14. Then it's actually what they're doing is similar to this one. Then the total number of cookies give me 10. Okay, so in general in mathematics, if L, M, and S are not integers, you can have multiple solutions. And actually, there's a hidden equation here. It's called integers. They're all integers. Then it's easy. And this is like 2 equations. I'm trying to give you, something can catch up this kind of equation, so they can be much easier to study basic math. So you take the difference. Take the difference means the top one minus the bottom one. 3L minus 1L, that's only 2L left. 2M minus M, only 1M left. S minus S is gone. 14 minus 10 is 4. Actually, what we're doing in the above computation is essentially the same here. Okay, then you say, okay, what kind of integers I can put here for L and M so I can get 4, right? And L cannot be 0, so L could be 1, could be 2. But if L is 2, M must be 0. Okay? So clearly there is only one solution. So L is going to be 1. Then L is 1 is 2, M should be 2. Okay, so it's a unique solution. Okay, yeah, this is, you can see the power of the equations in the future. The problems getting more complicated. You cannot just use like a, you know, like some kind of draw circles to the comparison directly. You have to introduce the parameters, you know, the variables, and then you do the computation. Yeah, do the analysis. Okay, so you're going to get another set of exercise, and those students who register for the congruent math, you're gonna participate in the contest very soon. After that, we are going to switch to the Singapore Challenge Math for 5+. Okay. Okay. See you. Bye. Bye. Bye.